Hey PCWorld fans, Adam here with Gordon. And Gordon, when Ryzen 7000 launched a couple weeks ago, the internet was aflame because AMD had not only pushed power consumption, but also their CPU 95 is the new normal. 95C is the new normal. Everything is running hotter and faster and uses more power. But now 13th gen is here. What's the story with 13th gen and power utilization?
Well, to get at that, what I do is I take the exact same components, well, same models, power supply, GPU, SSD, and coolers with fixed RPM and pump speeds, shut off all the extraneous crap. There's no fans, there's no other LEDs that are running. And I use external logging watt meters to record the power utilization of these machines.
The whole system power.
The whole system. So this is total system power, which I think is valuable. There's some people who look only at the CPU reporting using an internal software application. Some people also only measure the power on the ATX 12V rails. There's many, many different ways to do it. The way I like to do it is the way I pay for my electricity, which is how much these systems will use. Okay. So you're seeing it also used over time, which is very useful because if you're only looking at an instantaneous peak, I don't think that's quite as valuable. So I like to look at the power utilization while running, say, a fixed workload.
Okay, and what workload do you want to show off first?
So the first one we're going to kick off is Blender. And again, we're not going to get into the performance results here. For that, you got to go to the other video where we talk about performance. You can kind of see who wins here just looking at the power profile, though, because that red line is the Ryzen 9 7950X that people were screaming about using so much more power than 5950X. Yes, it did use more power, but not as much as 13th gen and or 12th gen. And so you can see the red line kick up to about 340 watts. Then it just drops back down to idle. When it's done, it's actually the one that crosses the finish line first, so that's why it drops. Next up is the blue line, which is the 12900K 12th gen i9 part. That is the slowest of all the CPUs here. It is using a little more power, but it also is taking significantly longer than that Ryzen.
Yeah, definitely.
Of course, the interesting part that is new to us here is the performance of the Core i9 13900K. You are seeing two lines, green line and purple line. The green line is the 13900K effectively set to its published spec of 253 watt PL1 and PL2s. That's basically what it is on paper. You might get that if you use like a smaller cooler. The other one, though, is the performance of the 13900K when it is basically unlimited. So some motherboards, when you install the CPU and you're setting the system up, will ask you, are you using a water cooler or an air cooler? If you're using a water cooler, great. We're going to set that sucker to unlimited. And by the way, we are going to use way more power because look at that 450 watts, right? I mean, it's over 450. It's almost 500 watts. It's about 480 watts, 490.
That is a lot of wattage.
Yeah, it's a lot of wattage. And honestly, is it worth it? Because it doesn't, you can see where that line drops. It doesn't exactly drop off that much faster, right? So it's using a lot of power and probably not giving you all that much, but it is there. The green line, though, is where the 13900K would be if you were using so-called stock. And I would argue, yes, it is using, looks like 60, 70 watts more than a 12900K.
That is more.
But it is considerably faster than a 12900K.
Well, it is also using, it's using more wattage than the 7950X.
Yes.
But it's actually slower
it is
than
actually
the 7950X.
And that is what has been awesome for AMD. Remember, they got a TSMC's most expensive node at work here. They got all kinds of efficiencies. And it has paid off dividends for them. Although when you look at idle power, it gets a little different. Because the idle power for all the Intel parts, a little bit lower.
Okay, well, what about if you run this test with a different benchmark? Are you going to get the same results?
So next up here, we're seeing Cinebench R23, and not that different. Again, we're seeing 7950X, even though people were screaming about how much power it used. When you're comparing it to 12900K and 1300K, I probably would say, yeah, okay, that's not that bad actually. Overall, Remember though, the Core i9 13900K is actually faster though, and actually for every sag you are seeing is every frame that is rendered, and they are pretty close. It's not a big advantage for the 13900K, but it is faster. It is still using a decent amount more power at 253 PL1, PL2, and it's using way more power when it's set to unlimited.
Yeah. Wow. Okay. Well, what about that? That's under all core loads. Well, what about single-threaded loads?
Yeah, I think that's one thing people really need to understand, because a lot of people go off on the narrative of, oh my God, it uses so much power when I'm using every single core all of the day. Are you really doing that? Are you really? You really are not doing that. I mean, yes, some of you are, but I can tell you, if you're here typing, you probably aren't the kind of person sitting there doing renders 23 hours out of the 24-hour day. So to me, also looking at single-threaded performance or power consumption is very important. And again, we're looking at Cinebench R23 using a single thread, and we are looking at the same thing before, the 7950X, the 12900K, and then the 13900K, basically at 253 watt PL1, PL2, and unlimited. And look, the red line that is using the most power on a single thread is actually Ryzen, right? And
that's interesting. I mean, not by a ton.
Not by a ton, not by a ton. But, you know, we are still seeing that generally the Ryzen is using more power, using a single core, and generally it does also idle slightly more. 20 watts, again, I'm not going to care about, but 20 watts is 20 watts. And then the green and the purple, as you can see under single-threaded workloads, it doesn't matter whether you're running a unlimited PL1, PL2 or running it limited to 253. It just didn't matter. Alder Lake 12th Gen is actually doing the most efficient work here with a single core.
Well, and actually, but I am surprised that the 12900K still uses the least amount of power here.
Yeah, no, it is kind of surprised. But again, remember, look, you crank up the workload, you're running, and then you see where those green and purple lines finish.
Yep.
You can see that we're not talking about performance here. That's over in the performance section. But I can tell you, the Intel parts are a little bit faster, right? And you're seeing that because it's done faster.
Okay, all right. Well, what about in more complicated benchmarks? Because, you know, the Cinebench is just looking at one thing. What about something like PugetBench?
Yeah, so same thing here. Again, we take PugetBench, which is using a real-world application and not exactly a slouch in needing powerful resources. It's using Adobe Premiere Pro, running it through a bunch of workloads, exporting it, scrubbing, running live playback. We record all of the CPUs again and how much power they're using. And I do want to point out, a lot of people have this misconception that because you are seeing all core loads on some CPUs be very, very high, that means I'm going to get really, really high workloads and everything like Adobe Premiere. Well, I got some bad news for you. Adobe Premiere is not using every single core all the time when you are using it. Yeah, it can use up often, and it can also use GPUs, but you can see in this chart, do I care? There are times when this is kicked off where Ryzen is actually using more power than both 13th Gen and 12th Gen. And there are times where 13th Gen is using more than 12th Gen and Ryzen 7000. On the right side is where we're getting to more GPU utilization, and you're up over 600 watts. And that's often combined because you're using that 13th Gen with a GeForce RTX 3090. But you're also looking at a fairly minimal amount of time, right? I don't think it really matters. I wouldn't really lose sleep. Again, if I'm really concerned about power and thermals, you know, and I push cores all day, Ryzen is the answer. If I'm pushing Premiere all day, I really say it's not that big of a deal. Because look at this. This is a real world application, and I can't really say one is really using, you know, less or more power. And all look, because that left side, the Intel systems can use less power sometimes.
Yeah, it is interesting to kind of, you would almost have to map out exactly what PugetBench is doing at that time, because yeah, there are some points where the Core i9 is using more, but there are some points where the 7950X uses more too. So it's kind of interesting to, you know, it once again always depends on the workload and what you're doing.
Yeah, never assume peak power consumption is what you're going to get all the time. which is what a lot of people do.
And that same thing shows up for PugetBench Lightroom. Right?
Yeah, this is using PugetBench running Adobe Lightroom Classic, runs it through a script of editing photos and then exporting them. The left side is where you're editing, where you're moving the mouse around, where you're switching modes into the developer mode, making adjustments to photos. And you can sort of see all those squiggly red lines concentrated on the left side on those very lightly threaded tasks. Ryzen, sort of what we saw with Cinebench earlier, single-threaded, using a little more power. Again, I don't care. That's not enough to lose sleep over, but generally on very lightly threaded tasks, it can use more power than even 13th gen, right? Mm-hmm. And then as you get to the right side is where you're getting to points like, hey, we're now going to export photos. Lightroom Classic, when you export photos, is when you really hammer all those cores. And those three big spikes there for the green and purple, that is very much likely the Intel CPU 13th gen cranking up every single core and using all that power. As we saw earlier in Cinebench, 400 watts, maybe up to 500 watts. We are seeing that happen when it is unlimited PL1, PL2, but and then you get over the right side where you're just doing it. But again, if you're looking at this, is this really enough to make you go like, oh my God, I really need to care? I would say you need to think of what you're doing most of the time. If you're going to sit there in Lightroom and for 6 hours edit photos and then do an export that takes half an hour, maybe it offsets all the power savings on Intel versus the power consumption on when you're doing your export. So you just have to decide based on how you do things.
Yeah. But what about if you're just doing basic things like web browsing?
Okay, so for that, I basically measured Chrome browsing using Web Expert 4. It runs a little bit longer, so it's a great benchmark to use. I skipped you doing the PL1, PL2 locked at 253 here because it was just 2 o'clock in the morning again. I did not want to do that again. But this is a little bit of a surprise to me because look, Core i9 13900K with the unlimited PL1, PL2 on this very light workload was actually using the least amount of power, even less than the Core i9 12900K. Again, we're not talking a lot of power.
That is weird.
It is weird, but AMD was using a little more at about 120 watts, where you're using sub 100 watts with that 13900K. And for the most part, a lot of that 12900K is right around 100 watts, a little bit under it. So again, if you're just going to sit there and not do much all day, Intel definitely has a nice advantage on very light tasks in power savings.
But enough do you think that would sway the needle on you buying a Ryzen 7000?
No. Again, I kind of think that's like one that's like, yeah, you're using a little more in idle. You're sort of mindful of that. But you do have to think of how you're using your PC. If you're buying a Ryzen 9 7950X, you need it because you are just hammering all kinds of cores in Blender. That's kind of where you get your payback. Your payback for eating a little more efficiency on your very light loads when you're screwing around just browsing the web. Okay.
Well, what about games? What about gaming?
Okay, so for gaming again, I skipped the whole locked PL1, PL2 because you can only do so many 2 a.m. benchmarking days. Every reviewer has a limit. I was at my limit, so this is unlimited. If anything, the performance is a little worse for Intel with it unlimited, but I don't think it matters because in most games, it's not using all of the cores of a CPU where it even matters. And we see that here where we're running total system power for Horizon Zero Dawn. I'm running the fixed benchmark, so it is a fixed benchmark. We are running that for 12900K with that dash line. The red line is 7950X, and the solid blue line is the 13900K. The winner is I don't care. I don't care. You're basically, that big fat GeForce RTX 3090 is sucking down so much power, it doesn't matter. We're up over 500 watts, almost 600 watts most of the time. And that is because everything is almost always GPU bound, and the CPU, unfortunately, is not doing that much, unfortunately.
Well, was this tested at 1080 or
this
4K?
is at 1080. 1080p, okay, and honestly, if I ran it at 4K, it would be even more even, because this is at 1080p too, folks. It just doesn't really matter that much.
All right, maybe it's just that game.
It might be. Game? I will say this is Metro Exodus. And this does 3 benchmark. This is 3 benchmark runs using the fixed mode. And again, Do I care? I don't care. The CPU that's using, or the system that's using most, is the 13900K, maybe 15-20 watts more than 7950X. The most efficient here is 12900K, but I mean, you're still eating over 530 watts. So are we really going to quibble over 50 watts when you're spiking it over 500 watts? I say no. I don't care. When you're gaming with a very powerful gaming PC and a very powerful GPU, it's just not going to get pretty, and the CPU doesn't matter.
Okay, well, when Ryzen 7000 did come out, AMD was like, "Hey, listen, we understand if you don't want to crank it all the way up to 95C and high power draw, we have eco modes that should help you on power draw and also help you in thermals." So Intel doesn't have any specific easy button to hit for eco mode, correct?
Yeah, in fact, when I originally did the eco mode testing, which you're seeing here, I had to manually set it in the BIOS. It has actually since been released in Ryzen Master. I've been seeing some reviews of it. It's kind of cool. You go and select, I want to run in this eco mode. You're seeing in this chart the results of the Ryzen 9 7950X running in Eco 65 and Eco 105. I think there's another mode they added into Ryzen Master as well. I haven't had a chance to mess with that. But so for the Intel part, for the 13900K, I basically took that and I limited it from, whatever default of 253 PL1 PL2 to 65 watt PL1 PL2, as well as 105 watts PL1 PL2. That basically means the chip never goes over 105 watt or 65 watt PL1 PL2, which may not really be the way to tune it, because I think if Intel did add a specific, we're picking a certain wattage mode, they'd probably have guidance to give you the max performance for a certain threshold. This is probably not the way to do it, but the fact that AMD talked about 65 watts and 105 watts, I wanted to basically test this way. And you can see the dash line at the bottom, dash red and dash green. Those are basically the Intel 13 Gen and the Ryzen 7000 in their 65 watt modes. And you can see the Intel system under load. This is all core too. This is not single core load. It's actually using less power than the AMD system, right? Because it's considerably, 20 watts less? Again, I wouldn't lose sleep over it, but even in Eco 65 watt mode, the AMD system is using about 20 watts more. And then if you're looking at the dotted green line and the dotted red line, same thing. At 105 watts for both of those parts, the Intel chip is using less, it's like almost 40 watts less power than the AMD chip.
Huh. So it's like in those quote-unquote eco modes that you set up, Intel's actually using less, but then at the stock performance of both, Intel then jumps up above the stock of the 7950X.
Yes, definitely. Of course, I think the thing is like, well, what does this mean? Saving power, how much performance do I give up?
Yeah. I mean, that is the question, right? Can you still maintain the bigger bar better, even if you're dialing back the power? Well,
so here you're seeing the results of Cinebench, again, R23. It's not that I love Cinebench or take money from Maxon to run this. I think it's just a great benchmark to run because everybody knows it, is familiar with it. It's very repeatable. These are the performance scores of the Intel CPU set at various different PL1, PL2 limits. You're seeing 65 watts, you're seeing the 65 watts. But earlier you saw in that chart like, hey, 65 watts, it was actually using about 20 watts less than the AMD part. So what if I juice that 13900K all the way up to 85 watts, right? What do I get then? Well, with a PL1 and PL2 of 85 watts for the 13900K, you're using about the same power of the 7950X on its Eco 65 watt total system, right? And the score is a little bit faster for AMD, but honestly, that is not really a big deal, right? 26,723 versus 28,655, not a big deal.
Yeah, so it's almost like the chart we saw before. Even though they were both running in 65 watt mode, Intel was using less power, yes, but it was also turning in a way worse score.
Yeah,
and
definitely.
The only time that it kind of matched the 7000 EcoWatt 65 was to go up to 105 watts. It's roughly equal there. So that is kind of
actually, well, yeah, if you were to say that, although I would say 27,000 versus 28.5 is pretty close. So 680, you can get pretty close. And again, AMD is more efficient, I think. So that kind of pays for itself. But is that enough? If you're talking about like 4% difference, it's pretty close.
Yeah, well, and then the other number I want to look at is the uncapped or unlimited power versus the quote unquote stock 253. 253 turning in a score of 39,000.
Yeah.
I'm sorry, 39,062. And the unlimited, all the power to the wall, is only turning in 700 more points.
Yeah, 39,783 when it's set to unlimited, which the behavior you're gonna get on a lot of high-end motherboards that are sort of tuned to give it to you.
I mean, it is bigger bar better.
It is bigger bar better.
But you're using a lot more power.
Would I eat that extra 80 watts to get that? I probably wouldn't. I'd limit it to 253, right? Or there's other ways to tune it to get more performance. You could do some of that undervolting stuff you like.
Yeah.
You could do some of that stuff.
Yeah, I mean, you're essentially, Gordon, I got to give you a high five because.
Oh, I said undervolting?
Yeah, you did it. You know what you're doing here? You're essentially undervolting these CPUs. We did it. Finally, we got Gordon to go into the BIOS and undervolt these CPUs. And yeah, we're getting some good gains here. So you just admitted that undervolting the 13900K to 253 watts is better than unlimited power.
Well, except that the score is bigger for unlimited. I'm pretty sure.
Rewind the tape.
39,783 is more than 39,062. Yeah, that's faster.
It's true.
I'm pretty sure.
But you recommended the other way. Okay, so then the other side of this coin is heat. That was the thing. We all saw the thumbnail from Gamers Nexus. 95C is the new normal, and I've done my own kind of experimenting with trying to limit the temperature of Ryzen 7000. There is still more to come. But what is the story with the 13900K? Is it that much? I mean, it uses much more power. How much more heat is that putting out? Well,
it's actually again, the AMD and Intel are. They are in an all pitch battle here to be the fastest CPU, the best CPU, because they want your money, and Intel also is swinging for the fences. So we're basically looking at the previous charts, performance. Consider the performance. Consider the power utilization you've seen before. Look at the uncapped, unlimited PL1, PL2. By the way, the TJ Max of the Core i9 13900K is 100C, and if you are running it uncapped, unlocked, PL1, PL2, it will go right up to 100C.
I mean, that's
right. It will go right up there and sit there all day.
You didn't limit this.
I did not limit it, and if you're actually if you're doing an average of everything, of course, that's going to have some of the lower scores considered, lower temperatures considered here. It's basically averaging about 97C across the entire run.
Okay.
Right? And of course, that is unlimited, which is the behavior you're probably going to see on a lot of higher-end motherboards because the motherboard companies, they want to give you the most performance, and bigger bar better is what moves people. So basically, the behavior is very similar to what you're seeing out of Ryzen 7000 out of the box. They run it right up to the max because that's how you win.
But if you limit it to the quote-unquote stock 253, you're hovering just barely over 90. What's the average on that one?
The average overall is about 88C, but honestly, most of it is sitting above 90. But you can see that you're 88 to 95C overall. I would say, hey, that's not bad. But again, remember, Intel specs a maximum temperature for this CPU. That doesn't mean you need to be 20 degrees C below that. It doesn't mean you need to be 30 degrees C below that for it to function. Intel is basically saying you could run this baby at 100 C until the end of time. And that is basically what AMD has said too. That's what our engineers say. That's what our lawyers say you can do, right? I mean, there's probably other caveats in there. It's like, well, we didn't intend you to run a server farm for the next 50 years, but if you're afraid that running these chips at max temp near max temperature, because not every single core will hit 100°C. A lot of times you'll get up to that, and the other cores will basically run lower. This is the total package temperature. I wouldn't worry about it. The freak out is not really warranted, because that really is a new normal. If they are going to say, we are going to give you a new CPU because you blow this thing up in 2 months or 3 months or 1 year, they are going to do it.
But I mean, at least you have the option to save yourself an average of 9C and only drop your Cinebench score by about 700 points.
Yeah,
So,
that's why, honestly, that is probably what a lot of people do. That's why people are really into the anti-overclocking with the undervolting scene. That's really big right now, and there are real dividends there, right? So 253 PL1, PL2 is 88 watts. And then look at say, remember we were looking at performance very similar to the Ryzen part at 105, 56C. You can get by really kind of limiting these parts, you can get really decent temperatures. Of course, the argument would be, did you buy this chip so you could give up all that performance? It's up to you. Some people just simply don't want to hear fans. They don't want to use more power, or maybe they just simply, don't like the heat generation. In the winter, though, it'd be nice.
That might be nice. But, once again, at the end of the day, we looked at the other charts of the PugetBench and things like that, and gaming, and it's like, well, it's not going to make that big of a difference. So I mean, we're
yeah,
it's fun to look at these, push it all the way to the max, and yes, you can push it further than Ryzen, for sure. But that's why we love the PCs, because we have tools in our tool belt to have the hardware run it the way we like to.
Choose the right tool for the right job.
But what you just showed was the max performance of Cinebench R23 using all of the cores. What about if you scale up the core count? How does it look between the 253 watt stock and the unlimited power utilization?
Yeah, I actually really wanted to find out, because it was curious to me that the boards are basically setting it to be unlimited. I'm fine with that, because honestly, I will say I did not have one single crash with 13900K testing at all. So that's, to me, is a pretty big, just shows you the stability. And that was with it unlimited. But I did want to know, at the stock 253 PL1, PL2, what do you get, especially from light loads to heavy loads? So I take Cinebench, I run it from 1 thread to 32 threads. Across the entire thing, you're seeing the scores, single thread, all threads, and it ain't no big difference here, because you're looking at lightly threaded, basically all within the margin of error. This is just simply, it's just everything all the way up to maybe the very tippy top, and you might get 2%, you might get 1% more performance by going with the unlimited PL1, PL2, but it's like, can you really justify that? But you can see definitely where you're getting the performance gains of going unlimited. I'd say I'm not that impressed by it. I don't think it's really worth it.
To leave it completely unlimited. You would much rather undervolt and set it to...
I would correctly volt it. But at the same time, it does run fine. I mean, there is an advantage where 2% of a very large number is decent. You're looking at 700 points in Cinebench. I wouldn't care about that. There's some people who do. But again, it's just one of those things where AMD and Intel are in this world, and everybody is just swinging for the fences, because it is a pitched battle here between these parts.
Yeah, definitely. Well, I mean, is 95C the new normal? I mean,
it's 100C on 13 Gen if you're running unlimited.
Yeah. Once again, if you plan on using these chips, to all the way to the max, yes, you're probably going to have to plan accordingly. Yes, it can use a lot of power. Yes, it can generate a lot of heat. But educate yourself. There are ways to limit that power without sacrificing too much quality or performance. And that's why we kind of like to sit down and look at the whole system and kind of go through all of the testing here. Gordon, thank you for doing this testing, and thank you for doing all the other testing. You should definitely go watch the other testing, and that's almost all the numbers there are at the stock 253. So if you're interested to see how it performs at that setting, go watch the other video. But yeah, I'm gonna have to do some of my own testing as well in the coming weeks, to kind of see how you can maximize performance by limiting some of the voltage and power draw and things like that. So more to come. If you want to see that, be sure to subscribe here on PC World. Thank you, Gordon. Thank you, everybody. We will talk to you later. Bye.